Hello everyone, welcome to my YouTube channel Easy Programming. I'm Naveen Mishra and I'll continue teaching you C language programs, how to write programs in C language. In my previous video, I have discussed about the topic pointers. I'll continue from the last point where we left, that is continuing pointers after pointer arithmetic. I would suggest you guys to watch my previous video before you start watching this video so that you will be able to understand how the things are working out. Okay, so let's start. Arrays of pointers. Previously in the video I have told you about how to declare a pointer. What we do is int star p, a variable is declared. But what if we want to create an array of pointers, that is more than one pointer? So just like normal variable, we can have an array of pointers as well. One can pass the whole array addresses or to array pointers or single variables. That is, once you have your array of pointers, you can pass the whole array or you can pass the individual elements, individual variables to this array. How would you declare the array of pointers? So you will say data type, then star, this represents that pointer variable, then any name of your pointer array, then inside this square brackets you will put a size of the array. For examples, you see here int star p5, you can declare it int, float or double, any data type. So here I'm trying to create an array of 5. So in the memory here 5 memory blocks will be created and 5 blocks will be indexed from 0 to 4. As you guys know, array starts from 0 and goes to n-1 size. Now let's try to do this practically. So I'm creating an array of pointers. I will include a header file. I'll add main function. I will declare a const here, size equals to 5, and I will declare an simple array of size. I will need an I variable for index. Printf, enter the elements in the array, and I'll start a loop. Start from 0 and goes to n-1 size, that is size minus 1, I plus, and I'll read the values here using my scanf function. Let's see if this program works first. So I'll compile and run my program. 5 elements. Okay, so it's working fine. Let's create an array now. Okay, so to declare an array of pointers, I'll say int star p5, that is size, and I will move this line where I am declaring all my variables, and just a second. And when user is entering the value, I'll put this value in the, I'll put its address in the address operator. Okay. Here I'll say printf /n index /t value /t address. I will print 3 values. I will have to use the for loop again, so I'll save my time, and here I'll say /n, first of all %d for index, then %t for value, then for address I'll use %u, comma I, comma a of I, comma pi, that it's storing the address. Okay, so let's try to compile and run the program. Enter the elements in the array. There you go. So these are the index values, these are the elements that I have inserted, and these are the addresses. Okay, so memory is allotted to array of pointers. So this is your here array of pointers. Okay, now let's continue further. Pointers to array. Now instead of creating the whole array of pointers, I can pass the starting address of array variable or any address of array variable to the pointer. The variable can be of any index. How would I do this? I simply have to use AND, just like here. Okay, but I will move this thing from when I am implementing pointers to array. Okay, so let's see here. Let's say we have these 5 elements. We declared an array in star p, and we'll say p is equals to ampersand a0. So this p pointer will copy the address, starting address of a to my p variable. So if you practically in the memory locations, in RAM 5 blocks will be created, 10 20 30 40 50 values will be placed here. These are the index values and these are the addresses. The starting address will be stored in the pointer variable. Okay, let's try to write this program as well. So I'll just copy this code to save my time, and instead of declaring the array, I'll simply do this. Okay, and instead of passing the value here, what I'll do is I'll say p is equals to a. Now by default it means the starting address of the array is copied to the pointer, and when I say p, when I print p, I'll also increment the p. Okay, this program is off, sorry, pointers. Run this file. It will do the same task, I think. Let's try, let's see. Yeah, it is doing the same thing, just copying the starting address and then moving forward, because here when I'm incrementing the pointer size, it is actually incrementing the address size. So 4 bytes will be added, and the pointer will point to the next memory address. Okay, so this is the topic of pointers to array, not array of pointers, pointer to array, or passing array to pointers, or passing array to pointers. Okay, so after using arrays, we can start with strings. So we can pass a string, or we can create a string using pointers. Okay, so the syntax is, you can put a star here. Now you don't have to put the size of the array or the character array, and you can put the value here. Let's see the example. I have written this program here. Okay, so I'll say char star ptr equals to Naveen. So this Naveen content will be stored in ptr, and there is no size specified in the ptr, so automatically it will take 6 bytes of memory space plus 1 for null value. Okay, 7 characters will be stored in the ptr. Now the starting address of ptr passed to new pointer variable char star p. Then I have started a loop for star p, that as long as you didn't get any null value, null character, as you guys know that when you store the strings, the end of the string is represented using null character. So as long as null character is not found, keep printing the character for me, and I'm incrementing the value by +1. So this will be your output. One by one, each character will be printed like N, A, V, E, E, N, and when it founds \0, that is null character, the execution of the program stops. So this is the program of pointers to string, and this is the output. Okay, now very important topic, pointers and functions. In pointers and functions, there are topics like call by value, call by reference, and you can also return the pointers address, or return the pointer or address from the functions. So a pointer to the function points to the address of the executable code of the function. Where your function is, where the executable code is stored, pointer points to that location. We can pass pointers to functions and return pointers from functions. We can do the both. Okay, so what we can do is, we can have pointers as address, or we can have pointers as return type. Let's start with the important topic first, passing pointer to functions. So I'll have two topics covered here, call by value, call by reference. You can also say pass by value, pass by reference. So these important topics are very important. So let's start with these. Okay, call by value. Let me write the program first. So I'll switch to new function, and I'll create a header file stdio.h, and the program is of call by value. So I have created a main function first. I use two variables a and b. I'll read the value from the user, enter the values of a and b, and scanf, I will use 2%d and read these values. Once I have the values, I would like to swap these values inside a function. So what I want to do is I will call a function swap and will pass the values to swap function. Okay, so here I'll create a function swap which have two parameters or two values. I will use a z variable and swap the codes. Z is equals to x, x is equals to y equals to z. Using third variable, I'm copying the value of one variable into another. Then I'll print the message /n inside the function printf /n a equals to %d/t, b equals to %d comma a, sorry, comma x comma y. Now don't get confused here that I am saying a and b and printing x and y, because inside the double quotes I can put anything a, b, x, y, s, a, v, kuch, anything. We can print anything. But the main thing matters is xy. This xy must match with these xy. Okay. And before calling this function, I would like to print the values. Like, I'll save my time. So before calling this function, what I can do is I can say before calling the function, and then again I'll copy this code and print here, and I'll say after calling the function, and here now I have to print a and b because inside main functions I have variable declares a and b. Okay, so these are the a and b variables. Okay, so let's see what happens. Call by value. Okay, replace it, compile and run. So here, there you go. The first of all, this 14th and 15th line are executing. A and b values are asked. Let's say 10 and 20. Now before calling function, I have values 10 and 20. Inside the function, these values are swapped to 20 and 10. But when we come back after calling the function, the answer is still the same, that is 10 and 20. Okay, so 10 and 20. So whatever the changes made in this swap function, is not affected by the, does not affect the variables value in the main function. Let me teach you in this thing graphically. So wait a second. Now there you go. In call by value, let's suppose this is a main function block, and inside main function I have two values a and b, whose values 10 and 20 are printed as I have shown you in the output, and they have these memory addresses 2000 and 2004. I am calling the function add. Sorry, I have changed the name here. I have named it add, but think of it as a swap function that I have done in the program. Okay, that I have done in the program here. So this swap is this add function. Okay, now I am passing to value to this add function, which are copied to x and y. You see here. So value of b is copied to y and value of a is copied to 10. Okay, but there are two separate memory locations. Here 2000 and 2004 memory bytes address locations are there. Here you can say 2008 2010. Sorry for that, I forgot to change this address. So suppose 2008 and 2010 addresses are here. So whatever value is passed from this function to this function, they are copied into separate memory locations, and whatever this swap function or add function do, it will occur only inside this function. So I have swapped the values, so 10 is copied in the y and 20 is copied in the 20 x. Since this occurs in the separate memory locations, there will be no effect in the values of a and b. So as the values are copied into the two new memory addresses, changes made in the variable in add function does not affect main function variable values. Okay, so this is how call by value works. Okay, now let's talk about the call by reference or call by address. So to save my time, I'll again copy this code and I'll say in refer. What we will do is, instead of passing the values, we will pass the addresses. So it is called call by address. Now, as you guys know, addresses can only be saved in pointers, so I have to declare these x and y variables pointers. So wherever I'm using x, I'll pass it star. It represents the memory references to star and y. Okay, now let's try to run this program. So I'll pass 10 and 20. Now you see here, before calling the functions, values of a and b are 10 and 20. Inside the function, value changes to 20 and 10 because of the swapping code, but after calling function, the value remains changed. Let me try to teach you how this thing is doing, how this thing is working. So let's try to say call by address. So as you guys know, as I have told you in the previous call by value program execution, I have created a main function. Two a and b values are there, two memory addresses are there, but this time when I'm calling the functions, I'm calling it using AND. So addresses are passed. So to catch the addresses, I have pointers. So these addresses are passed this time, not the values 10 and 20. Addresses are passed this time. And when I'm implementing the swapping code, the swap values actually swap the values of main function, and add function or swap function does not have its own value since they are using the same memory locations. So since the values are changed in the main functions, so the effect will be shown in the main function as well. So as addresses are copied to the pointer variables, changes made in the variable in add function will affect main function variable values as well, as I have shown you here in the program. Okay. So this is a call by reference program, and this is call by value program. This is very important in the theoretical parts of the students. For example, BTech and BCA students, they will have this program quite often in their midterm exams or the final exams. Okay, so theoretically you can have the differences of these as well. So these are the differences of call by value, and these are the differences between call by value and call by reference. Here the values are passed as arguments, so the value is copied to the variable. Here the addresses are passed as arguments, so the addresses are passed to the pointers. So here the variables are used, here the pointers are used. The original values of the calling function do not change, as we have implemented it practically in the program, but here the original values do change. Actual and formal arguments are given separate memory locations. Call by value, as I have told you, that you have different memory locations in the call by value, but not in call by reference. It works only for the local variables. It works for the global variables as well. Generally, int, char, float, double primitive data types are passed as arguments. Pointer objects are passed as arguments. So this is the syntax of definition and call, and we have implemented it practically in the programs. So let's study about the topic now, returning pointers from functions. So C language allows us to return the pointer from the function as well. To do so, we have to change the return type from a basic data type to a pointer variable using the star operator. Okay, so this will be done to return the value from the pointer functions. And when we call the function which is returning the pointers, we have to receive its returning value in a pointer variable. Okay, now let me try to do this for you guys as well. So I'll again save my time and copy this code. Now here I'll keep it simple and I'll declare a z variable. No arguments will be used, but I will return a value. So I'll say int star, and I'll ask the value from user, enter any value, and this will be replaced by scanf. And I'll return the address of z like this. I can put it inside the circular brackets. Okay, and when I call this function, I have to call it in a pointer variable. So I'll declare a pointer variable and I'll say p is equals to swap, that's it, printf /n value equals to the address equals to %u. I'm not sure that both of these things will work, but I can try. So I'll say star p comma. Okay, so this is returning, and let's compile and run this file. Enter any value, and there you go. So both of things are working fine. The address is passed from this function to this function using return type. So I am returning an address, so I have mentioned an AND operator here. Now since I'm returning the address, I have to copy it in a pointer variable. So this is a return type of pointer, and whatever pointer variable is passed from here is copied in this p variable, which is also a pointer, and I can use these values in the main function. So you can do return, you can return the value from here as well. Thank you very much. That's enough from this video. Thank you very much for watching my video. Keep on subscribing and sharing my video. Thank you very much. Cheers. See you in the next video.